So before I get going into what I'm going to teach today, which is alligations, it's not going to take very long, honestly. It's a very short lesson. Are there any questions about 2.5 and 2.6 since we weren't able to have class on Tuesday? I apologize again. I'm much better now, but Tuesday I was not in any shape to be teaching. So I apologize again for having to just do a recorded lecture instead of having a live lecture. But are there any questions about the material from that lecture or anything like that? Okay, so in the lecture on that was 2.5, 2.6, that lecture, I went over finding solutions using so creating a third solution using two solutions themselves. And so today's lecture it's called Alligations. And this is from a different textbook. And so in the content in Eagle Online, you're going to actually do paper problems instead of an assignment, instead of like a digital assignment like we've been doing. And so there's a separate textbook that those problems come from. And that's all listed in that section in Eagle Online. But this is a way of doing it, and it's using the pharmacy tech program. So let me share my screen with you. So that's the reason that we go over it in this class. Excuse me. And so, so again, they're using the pharmacy tech program, and it's another way to solve solution mixture problems. And so it says a technician must prepare 120 grams of 2% hydrocortisone ointment using 1% ointment and 2.5% ointment. How much of each does the technician need? So before we get into the alligation grid, I want us to do this problem using the method that was covered in 2.5.2.6, which the method in 2.5.2.6 says the concentration, is it C or does it start with V? Let me just check to make sure I'm being consistent. Nope, it's V. So it says the volume of solution 1 times the concentration of solution 1 plus the volume of solution 2 times the concentration of solution 2 equals the volume of the final solution times the concentration of the final solution. So again, before we jump into this alligation stuff, because it's just a different way to think about this, I want us to solve it using the method as before. So I'm going to copy this information. So we've got 120 grams of 2% hydrocortisone ointment. So we want to make 120 grams of 2% ointment. Using a 1% ointment and a 2.5% ointment. Now, in this description, there's nothing about the quantity of those two ointments that we're going to use to make the final one. The one thing that I talked about in the recorded lecture is that you always want to make sure that you're resulting your final solution, that concentration is between the two starting solutions. And so because 2% is in between 1 and 2.5, we're good. We can actually make this. So if we think about this, the concentration for solution 1 is going to be 1%. The volume of solution 1 is going to be X. The concentration for solution 2 is going to be 2.5%. And the volume for solution 2 is going to be Y, because again, we don't know that. For the final, the concentration of the final is going to be 2% with a volume of 120 grams. Now we know that in order to make the volume of the final, it's the volume of the first one plus the volume of the second one. So that means 120 is going to equal to X plus Y. Now, relating these concentrations, we don't put them in as percents, we're going to put them in as decimal numbers. So 1% is going to be at 0.01, 2% is going to be 0.025, and the 2% is going to be 0.02. So using our formula that says C1 V1 plus C2 V2, or I guess sorry, I'm going backwards. We want to do V1 C1. It doesn't really matter because with multiplication order doesn't matter, but I'll be consistent. So V1 C1 plus V2 C2 equals VF CF. So plugging in what we know, we've got V1 is going to be X times 0.01 plus V2 Y times 0.025 equals volume F 120 times concentration F, which is 0.02. Now, continuing to simplify, we're going to have 0.01 X plus 0.025 Y equals, and multiplying this, 120 times 0.02 gives us 2.4. Now we're trying to solve for the quantity we need of each of these, right? And when we look at this equation here, we can't solve this equation as it is because it has an X and a Y in it, and we can only solve equations that have one variable. So that's when we're going to come over here to this other relationship. There's a reason why we know that the sum of the two volumes equals the final volume. So if we solve for one of these variables, let's say we just want to solve for X, that means I'm going to subtract Y from both sides. We have 120 minus Y equals X. Now the reason why this is helpful is that I can then take this amount and go over here, and I can plug it in for X. And again, how did I get that X by itself? All I did with this equation up top is I just subtracted Y from both sides, right? Subtracting Y from both sides, 120 minus Y is what's going to be written in that circle. So if I substitute, then I'm going to have 0.01 times 120 minus Y plus 0.025 Y equals 2.4. Continuing to simplify, we now need to distribute. 0.01 times 120 is going to be 1.2 minus 0.01 Y plus 0.025 Y equals 2.4. Continuing to simplify, we're going to combine our like terms here. So 0.025 minus 0.01 is going to give us 0.015 Y plus 1.2 equals 2.4. Subtract 1.2 from both sides. 0.015 Y equals 1.2. Divide both sides. And we get 80 grams. So remember, the Y has to do with, if we scroll all the way out, the Y had to do with the 2.5%. So we need 80 grams of 2.5%. And since it has to equal to 120, X is going to be 40 grams of the 1%. And again, that 40 grams came from doing 120 minus 80. And that's how we got the 40. So using our original method that we had from Tuesday, we know what our answer is. So we're going to go back to the alligation and we're going to actually look at this new method of doing this. We have the solution now, so we know what to have in mind for what we should be getting. So let's go back and look at that. So when we look at alligations, we use this grid, and to set up the alligation, we have the higher strength that goes in the top left, and the lower strength goes in the bottom left. So the strength amounts go right here and right here. When we're talking about the strengths, we're talking about the strength that we're using. So we're using a 1%, we're using a 2.5%. And then you're going to have the desired strength goes in the center box. So that's where that 2% is going to go. Now you can see none of this has to do with any about the quantity yet. It's just all about the percentage of the strengths. We then subtract along these diagonals. Now it's going to seem weird, but when we subtract, even if it ends up being a negative amount, we put a positive. And so the steps say to find the difference along the diagonal. So we first need to put our percent strengths in. We're going to leave these as the percent numbers. We do not need to convert them to decimals. So we're going to do 2.5 here and 1% down here. Our desired strength is 2%, which goes in the middle, right? So setting up our grid, again, the higher strength goes in the upper left, the lower strength goes in the lower left, and then the desired goes in the middle. We're now going to subtract along the diagonals. So if I go this direction along my diagonal, I'm going to do 2 minus 1, which is 1. Going this direction, I'm going to do 2.5 minus 2, which gives us 0.5. So once we get these values, it tells us the number of parts of the higher strength and the number of parts of the lower strength. And what does that mean? So first of all, if we look at our steps, we're going to add the right column to get the total number of parts necessary. So we're going to add this column up. So total parts, we're going to be 1 plus 0.5, which gives us 1.5. Okay. And then we need to set up the proportions. So we're going to say, we're going to allow for, we're going to say that we want for quantity of 2.5%, we're going to have that equal Y, and quantity of 2%, we're going to have equal, or not 2%, excuse me, 1% is going to equal X. Now, the reason I'm using the Y and X is to match what we did before, just so that we're not getting confused. So in order to get the amount of 2.5%, we're going to set up a proportion that says Y is to 120 grams. And so what this is saying is how much of that 120 grams comes from the 2.5%. And it's going to equal 1 part, and I'm getting that 1 part from right here, right? The 2.5 goes with the 1 part out of 1.5 parts. It doesn't matter that there's a decimal in that fraction. We're just going to cross multiply. So we're going to take 1.5 times Y equals 120 times 1. Simplifying, 1.5Y equals 120. Divide both sides by 1.5. And Y comes up with 80 grams. Now, in order to solve for X, we can redo these proportions. Okay, so if we want to do the 1%, then we're going to have X over 120 equals 0.5, because again, that's how many parts we have the 1% over 1.5 total parts. So again, this is the denominator. If we cross multiply, we're going to have 1.5x equals 120 times 0.5. 1.5x equals 60. And dividing by 1.5, we do in fact get 40. So we could solve for the amount by doing that proportion like I did in the blue, or you could have also just done 120 minus 80, giving us 40 grams. So what I'm trying to show you here is that all we get from these alligations is the visual organization. It's a visual way to organize our work in order to be able to solve these mixture problems. Okay. And these mixture problems work when we're taking two solutions, combining them to make a third solution, okay? So we're gonna go to the next page. And we're gonna look at this practice. It says a supply room stocks two concentrations of alcohol, 5%, or excuse me, 25% and 5%. How much do you need of each to make 200 milliliters of 10%? So starting out, we're gonna put our higher strength up here, our lower strength down here, and our desired strength in the middle. Then we're going to subtract along the diagonals. And then once we subtract, we have to come up with the total parts, which is we add these two together. And we come up with the total parts are 20. So I want you to finish finding how much we need of each in order to make 200 milliliters of 10%. If you need me to go back to the previous page, just let me know. I'm going to go blow my nose. I'll be right back. So again, if you want help setting this up, we're looking at x over 200 equals 5 over 20, and y over 200 equals 15 out of 20. Those are the two proportions that we're solving. So if we cross multiply, I'm going to take 20 times x equals 5 times 200. 5 times 200 is going to be 1,000. Dividing by 20. And we get x equals 50. And that's 50 milliliters. And the question is, what is that 50 milliliters of, right? We got to know, what are we even talking about? Well, remember the 5 parts went with the 25%. So it's 50 milliliters of 25% alcohol. So again, we can choose to cross multiply and just divide for the what am I trying to say? For the second proportion, right? Or we can just use the subtraction, which is going to say 200 minus 50 equals 150 milliliters. And again, if it's 50 milliliters of the 25%, then we need 150 milliliters of the 5%. So again, you can choose to solve that second proportion, right? This one right here, or you can just use that subtraction. If you know that you need that much to make up the total, then you just can subtract and find the difference. So some of the previous problems we've done have involved water, and we can use this method with water as well, because water is great because it has a 0% concentration. So number 2 says, how many milliliters of water must you add to 500 milliliters of a 10% stock solution of sodium chloride to make a batch of normal saline? And normal saline has 0.9%, is a sodium chloride 0.9% solution. So when we think about water, water has 0% concentration, okay? And we don't know the quantity. Okay, so for the water, the concentration is going to be 0%. The volume, we don't know. We'll just call it X. And we want to add it to a stock solution of sodium chloride. So the 10% solution. Again, the concentration is going to be 10%. The volume is going to be 500 milliliters. Okay. And then if we look at, we want to make the total, the final, we have got a final concentration of 0.9% and a volume. And since we're combining it, we've got the volume of the water plus the volume of the 10% solution. Okay. So this one's a little bit harder, right? Instead of getting our final volume and working backwards, we're given an initial volume and have to work up. We can still use the percentages though, and still use this Alligations model. So we know our higher solution, 10% goes up here, our lower solution, 0 goes down here, and our desired concentration, 0.9% goes in the middle. If we subtract along our diagonals, we're going to have 10 minus 0.9, which gives us 9.1. Going along this diagonal, I'm going to have 0.9 minus 0, which is just 0.9. If we add up our parts, okay, add them up, total parts is going to be 0.9 plus 9.1, which gives us 10. So the piece that we want to find out, the answer, the question that they're asking is how much water. So we want to focus on this 0%. So we're going to say X is to the total X plus 500 as, and how many parts do we have? We have 9.1 to 10. Okay. So it feels a little weird because we have a variable in the numerator, a variable in the denominator, but they're still the same variable. So we can still solve this equation. So we're just going to cross multiply. We're going to do 10 times x equals 9.1 times x plus 500. We're going to simplify by distributing this 9.1 through. We'll do 500 times 9.1. And that's going to be 4,550. We're going to subtract 9.1x, giving us 0.9x equals 4,550. Dividing both sides by 0.9. And we get x equals 5,055.5 repeating, which will round to 5,055.6 milliliters. So that's how much water we have to add. If we were to come up with the total batch, the total thing is going to be 5,055.6 plus an additional 500. So our total solution that we would be making is going to be 5,555.6 milliliters, but that wasn't the question that was asked. The question was asked just how much water do we have to use? And we have to use, we have to use this much water. So some people like the alligation method a lot. Some people don't. Some people prefer to just use the formula. That's perfectly fine. It doesn't matter. They're both going to turn out with the answer. Okay. But again, these alligations are what you want to use when you have two solutions that you're combining to make a third solution. So, like I said, there wasn't, it's not a big section. And so if we go to your to Eagle Online, let me change my screen share. So we have the note pages. That's what I obviously just wrote on today. There's a video, which is basically like just another version of what I just taught. And then here is your the PDF that you're going to use to do your homework. And then this is where you need to turn in your notes. This is where you'll turn in a copy of your homework, and then you can check your homework solutions here. There are some suggestions. So we're going to use this document. You're going to do numbers 1 through 10. When it says 1 liter, you're going to use 1,000 milliliters. And then number 1, when it says 1 to 100, they mean 1 liter is the resulting solution of a concentration of 1 over 100 or 1%. When in number 5, it says 1 to 30, that means 1 over 30. And SFWI number 8 means sterile water for injection, and you can use the concentration of 0% for this. So those are some hints. Ignore this. I'll take this out. I've already obviously posted the solution. This is a holdover from when I taught this class last semester. So that is everything to do with alligations. I know you did your quizzes this week. I'm going to get those graded today and tomorrow, so I'll get those uploaded. And then next week, we look ahead. On Tuesday, when we come back, we're going to be reviewing for the exam. And so I'm going to post a review assignment as well that you can use to review for the exam. And then next week, the first exam will will release, and then you'll have that to do. So I'm going to get the review posted. I would like you to look through that. The review is not required, but I do encourage you to do it. And then lecture on Tuesday will be me going just through questions that you have. I'm not going to actually formally lecture. It'll just be what questions do you have, and we'll go over those. So again, next week we have our first exam. The review for it I'm going to post today, so you can review that. And then for lecture on Tuesday, bring your questions about all the content for the first chapter, and we'll go over those. Okay. So any questions for me before I let you go? Okay. Well, as usual, please email me if you have questions. And I will talk to you all next week. All right. Have a good weekend. Bye, everyone.